Oliver, and this is the topic about sales tax and discount problems. In fact, they basically are versions of the percent increase and decrease problems that we've talked about earlier. But what we're going to do is set them up in formal equations here, which follow exactly what happens when you're at the store. And it gives you a good insight into how equations can be used. Now, let me first talk about an example here, a sales tax one. And it says you paid $90.10 for clothes at a store. If the sales tax rate is 6%, what was the cost of the clothes before the tax? Well, 95, if not 99% of the folks walking down the street will get this one wrong, because what everyone tends to do is take the sales tax rate times the total amount you paid, 90.10, and figure that's the tax. Dead wrong. This 90.10 already includes tax, not only the cost of the clothes, but the tax itself. If you turn around and take 6% of this, you're getting 6% on the clothes, but also another 6% on the sales tax, and that's what makes it wrong. Well, it's not difficult to get something like this right. All you do is think about what happens at the store. So, let's say C equals the cost of the clothes before the tax. Well, think about what happens at the store. They charge you for the clothes, okay, and we're using the letter C for that. So when you go to the checkout counter, they're charging you the C, but they're adding on to that the sales tax. Okay, well, the sales tax is 6%, but it happens to be 6% of the amount you bought. Think about this for a second. If you buy something for $1, 6% of $1 is 6 cents. But if you buy something for $100, 6% of $100 is $6. You got to take that 0.06 times whatever the cost was. So we're going to take for the sales tax exactly what they do at the checkout counter, 0.06 times C. So here's the cost of the clothes, here's the cost of the sales tax, and that's the total amount that you end up paying, which in this case is $90.10. Okay, well then, notice that these are like terms. Officially, this is a +1C. You don't see a sign here, so we could put a plus. You don't see a number, we could put a 1. And since they're like terms, we can add those together. Okay, well, combining those, what we get is 1.06C, which equals, of course, the 90.10. Okay, well now, let's turn around and solve for C. We simply are going to divide both sides by the 1.06, so here we go, 1.06. The same thing over here, 1.06. The 106's cancel out on the left. We get the cost equal to, well, now it's time to go grab your calculator, get this one worked out. So we're going to take the $90.10 and divide that by, let's see, the $90.10. Let me get that in. And then divide it by the 1.06. And if you did that, you should come out with 85. And of course, it's dollars right on the button. Now, let's check this to make sure it's correct. If you bought something for $85, here it is, and they had 6% sales tax on this, well, what's the 6% sales tax? 6 times 5 is 30, carry the 3. 6 times 8 is 48, and 3 is 51. And we got 1, 2, 3, 4 decimal places. So the tax is $5.10 on $85. Well, if you take $85 and add $5.10 to it, you get $90.10 right on the button. That's exactly what the cost of the clothes was. So you can prove that this is correct. On the other hand, if you try that shortcut that doesn't work, take 6% of the 90.10 and come up with the sales tax, subtract that from this, the original cost of the clothes you get. If you go back and check it like this, it will not work. Okay, so let's point out to you what's going on here. This is simple to understand as long as you don't fall in that trap of what you think will work and it doesn't. Mimic what happens at the checkout counter. They charge you again for the full cost of the clothes. Here's the C. And they add on the sales tax, which if it's 6% is 0.06 times C. Well, those two things combined are the total amount that you have to pay. And if you turn around and solve this, you can come up with what the original cost is, and then you can prove to yourself that yes, indeed, that is the correct answer. Okay, well, discount problems work in a similar way. There are certain types of word problems that have the same type of form, but sometimes it's a plus, sometimes a minus. The sales tax was being added on, so we had a plus. Now let's look at this. You paid $44.80 for clothes at a store during a 20% off sale. What was the regular price of the clothes before the sale? Well, let's say that R equals the regular price. Okay. Now, what are they going to charge you? Well, if it wasn't the sale, you would have paid the full R, but because of the sale, they are subtracting amount from that. And what is it? 20% that's off. Well, we can make as a decimal just 0.2 for that. You don't need to put the 0 here unless you really want to. And of course, like it was with the sales tax up above, it's 0.2 or 20% of what the original cost was. It's the original over here. So we get R minus 0.2R. This is the sales amount that's being reduced. And that, of course, is the price you end up paying, which in this case was $44.80. Okay, well now let's solve this again. Officially this is a plus 1R here. Well, these are like terms, but when you combine them, this is subtracting. So you end up with 0.8R when you combine these two guys equals 44.80. Now, this makes good sense. There are other ways you can do this. You can actually work a lot of these in your head. Think of it this way. The whole original price was 100%. Well, if there's 20% off of the 100%, that means there's 80% left. You see this 0.8 right here? That represents the 80%. We get it solving it this way as well, and this is a pretty standard approach to take. Okay, well now, to find out what that regular price was, we divide both sides by 0.8. Get out our calculator here. The regular price better be more than $44.80. So I get $44.80, and I turn around and divide that by 0.8, and I come up with the original price, R here, equals 56. Okay, now again, we can check that to make sure it's correct. If the regular price was $56, let's figure out what 20% of that is. I can just multiply by 0.2. 2 times 6 is 12. Carry the 1. 2 times 5 is 10, and 1 is 11. There's a single decimal place, so you're saving $11.20. We'll take that 56 original, subtract the savings, 11.20. We've got to do a little borrowing here to be able to get this down. Let's see, just a 10 here. We get 0.80. 5 minus 1 is 4. 5 minus 1 is 4. There it is. That's what you'd have to pay, which of course is exactly what you were charged here, $44.80. Okay, well, having checked this again, we can see that these methods work. And although there are other ways you can do these, some of them, in fact, a little bit quicker if you can keep track of the percent changes in your head, this way here works these out really nice. Okay, well, let's look at some examples. We talk about this as being sales tax and discount, but as we go through some of the examples of the homework problems here, we'll see that there are other problems that it also applies to. Any kind of increase, decrease will work with these guys. Okay, you bought home supplies for $48.99. If the sales tax rate is 6.5%, what was the cost of the supplies without the tax? Well, let's say C equals cost before the tax. In other words, their regular price, and the tax, of course, is added on. Remember, mimic what happens at the checkout counter. you're going to pay the full cost C, plus you're going to pay sales tax. Well, the rate is 6.5%, so that's 0.065. But of course, 0.065 times what the original cost was. So here's the cost of the supplies. Here's the sales tax. That equals the total you pay, which is $48.99. Okay, let's turn around and combine these together. They are like terms here. This is officially plus 1C. So what do I end up with? 1.065C when I combine these equals the 48.99. Now, of course, simply go through and divide both sides by the 1.06. Let's do that. Here we go. 1.065 to be exact on it. Okay, well, let's see what C ends up being here. The cost of this, and again, get your calculator handy. 48.99. We're going to divide that by 1.065, and I come up, looks like it's $46 right on the button. So that was the cost of the supplies you bought. If you figured out what 6.5% tax was on this and added it back, you'd get this guy right here. Okay, let's look at another sales tax type of problem here. You bought clothes at a 20% off sale, and at the sale they cost you $70.80. What would they have cost you before the sale? Okay, well, let's say R equals the regular price. You can use any letter you want here, but let's say we use R. So what happens this time is we've got the same form as the sales tax, but instead of having a plus, we've got a minus. Why is that? Because the discount is reducing the price. Well, again, this is 20% off, so minus 0.2, that would be the 20% as a decimal. But remember, of course, it's 20% of the regular price, so 0.2 times R. So the regular price minus what you save equals what you pay at the sale, 78.80. Okay, now, remember, we combine these guys. This is officially a plus 1R minus 0.2R. Positive wins by 0.8R. Now, simply set up the equation simplified and divide both sides by 0.8. Here we go. The 0.8's, of course, reduce out here, so we're going to get R equals, well, again, it's time to go grab our calculator here, 78.8. And we turn around and divide that by 0.8. And we better come up with a regular price higher than 78.80. And what do I come up with? I've got 98.50. And again, we should put the dollar sign on that, okay, to put the proper units. Okay, well now, let's take a look at something that follows the same path, but is not exactly a sales tax or a sale discount type of problem. A business fee decreased 5% to $152. What was the fee before the decrease? Well, we could say F equals the fee before the decrease. Okay, well, what's going to happen is there was the original fee, but now it's decreased 5%. Well, this is exactly like a sale. Okay, we're reducing the price by the 5%, which of course remember now is 0.05. Make sure you get that correct. And of course 0.05 times what the original fee was. And what are we paying now? $152. Okay, well, once again, simply combine these two guys. This is officially plus 1F minus 0.05. That gives me 0.95 of the original fee, which of course you could have figured out. Remember, the original fee would be the full 100%. And if you're paying 5% less, then that means you're paying 95% of that original 100. Well, there's the 0.95. This always gives you the exact value right here. And of course, that's still equal to the 152 on the right. So now divide both sides by 0.95. and we get the fee, the original amount of it here. Better be more than 152. So we get 152, and we divide that by 0.95. And what do we come up with? 160. So the original fee was $160. If you figure 5% of this and subtract it from this, you'll get the 152 that you're now paying. Okay, so percent increase and decrease problems follow the same thing here. Let's look at another example. This season, the number of city soccer teams was up 50% to 27 teams. How many teams were there last year? All right, let's say T equals the number of teams, okay, last year. Okay, well, here's what happens. We start with the T teams that we had last year, but now, this season, the number of city soccer teams was up 50%, so it's increased. Well, this is like having a 50% tax rate being tacked on. It's going to increase it, but it's going to increase it by, well, the 50% is 0.5, and of course it has to multiply the variable again. So, the number of teams last year plus the increase this year equals a total of 27 teams. Well, here we go again. We've got like terms. Combine these. We get 1.5t equals 27. Divide, of course, both sides by the 1.5. Here it goes. Okay. The 1.5s cancel out. That's, of course, why we did it. So we end up now with t equals, and you could figure this one out in your head, but let's go ahead and use our calculator. Take the 27 and divide by 1.5, and you come up with 18, and of course it's teams here. So what did we have last year? 18 teams. Okay, here's another one, an increase type of thing, like adding on some sales tax. A property bill increased 1.5% to $905.38. What was the bill before the increase? Well, let's say B equals the bill before the increase occurred. Okay. Well, again, work this one. Since we're having it increased here, it's like a sales tax. So we had the original bill, and they're adding on to it another 1.5%. Now convert that to a decimal. Remember, it's going to be 0.015. Make sure you get that correct. And then, of course, times the B. And that's going to equal what you're paying now, which is the 905.38. Okay, well, as we've done before, what happens is we end up combining the like terms. It's positive, so I get 1.015 times B, that's combining these two B's together, equals 905.38. Well, the next thing we do is divide both sides by the 1.015. Here we go, 1.015. The 1.015s in front of the B's reduce out. That, of course, is why we did that. So what do we get B equal to here? Well, grab your calculator again. We better have something less than 905 because that's what it is this year with the increase. So it had to be lower the year before. Let's see what we get. 905.38, and we're going to divide that by the 1.015, come up with 892. So what was the property tax bill the year before? $892. With a 1.5% increase, it went up to the 905.38 up here. Okay, well, hopefully you're seeing the pattern of how these guys work, and there are lots of different types of problems that percent increase, decrease. That's basically a sales tax, which is a percent increase, and a sales, which is a percent decrease, so you can see why all these other increase, decrease guys work with this as well. Okay, let's look at this one here. This year, school enrollment increased 4% to 468 students. What was the enrollment last year? Okay, let's say E equals last year's enrollment. Okay, again, you can use any letter you want. So, starting out with how many students were in last year, there's an increase, so that means we're adding, and 4% is 0.04, and of course, times the variable we have, E, and that now equals this year the 468 students. Okay, well, once again, we can combine the like terms here. I get 1.04E equals 468. Divide both sides by 1.04. Here we go. And we better end up, since it's been an increase this year to 468, there better have been less last year. And one of the things you can see as you go along, anytime what we're dividing by here is more than 1 downstairs, that'll make the value smaller. If what we're dividing by is less than 1, that'll make the value larger. So since the 1.04 is greater than 1, our answer is definitely going to be lower. But let's go ahead and get what it is. E equals, again, get your calculator, 468. And now we're going to turn around and divide that by 1.04 and come up with 450. And of course, remember, this is students, so be sure you label it. Okay, well, let's look at a utility bill example here. This month, your utility bill dropped 2% to $18.13. What was the bill last month? Okay, well, let's say B equals last month's bill. Okay, now, we've got a drop, which is a decrease, so we know we're going to start out with what it was last month, but it's gone down because it's dropped. And what do we have? A 2% decrease. Now remember, 2% as a decimal is 0.02. So we have to, of course, multiply that times the B, because it decreased 0.02 of what last year's bill was. Well, think about this for a second. Last month's bill here was, if we think of it as the full bill, 100%, and it's gone down 2%. That means 100% minus 2%, we better end up with 98% of what we had last time. And of course, when we finish up this equation and collect the like terms, right here, what we're going to end up with, plus 1 minus 0.02, is 0.98b, which represents that 98%. Okay, well, that, of course, equals 1813 here. Divide both sides again by the 0.98. Now, notice this. Since this, what we're dividing by, is less than 1, our answer is going to be a bit larger than this. The 0.98s cancel out on the left. We get the B all by itself. And now let's go ahead and get our calculator again. We've got 18.13, and I'm dividing that by 0.98. Okay, and we end up with $18.50. Don't forget, of course, to label it with the dollar sign. That's what your bill was last month. If it went down 2%, this month then it's at the $18.13. Okay, well, let's look at one last example here. I think you've seen plenty of these and should be able to handle this fine. Here we have a city budget increased 3% to $2,533,800. What was the budget before the increase? Okay, B equals budget. Okay, before the increase. Okay, well, again, this is like a sales tax problem. We're adding on 3%. So we have the original budget plus, and it's a plus, of course, because it's increasing here, not decreasing, but increasing. 3% now is 0.03, and of course it has to be times the B again. Okay, what's that equal? Well, this big number here, 2,533,800. Okay, next thing we're going to do is combine the like terms, and what do we end up with here? 1.03 times B, again, equals this big guy on the right, 2533,800. I guess I could put the commas in there. There they are. Now, let's turn around and solve for b, which means we got to divide by 0.03. Well, okay, remember, this 0.03 is larger than 1, so that means the answer is going to be a bit smaller than this. And the budget before the increase was smaller. Its increase is now larger there, so that's what better happen. Okay, b equals, okay, so get your calculator, kick in the 2533,800, and we're going to turn around and divide that by 1.03, and we end up with 2,460,000. There it is. And of course, don't forget to put the dollars notation on it.